Dear students, let us continue our discussion on complex numbers. Let us look at this question, question 67. If three complex numbers are in AP, then they lie on. Where do they lie? Do they lie on a straight line, a circle, a parabola, or an ellipse? Okay. So given that three complex numbers are in AP, so I take them as Z1, Z2, Z. Let Z1, Z2, Z3 be three complex numbers which are in AP. When these three numbers are in AP, then if A, B, C are in AP, then we know 2B is equal to A plus. So from this I can write 2Z2 is equal to Z1 plus Z. Or from this I can say Z2 is equal to Z1 plus Z3 divided by 2. Z2 is equal to Z1 plus Z3 by 2. This suggests that Z2 is the midpoint of the line joining Z1 and Z3. See here, Z1 is here, Z3 is here. Z2 is the midpoint of the line joining Z1 and Z3. So this is the midpoint. That means these three must be collinear. They must lie in a straight line. Then only Z2 can be the midpoint of Z1 and Z3. Then that suggests that they lie on a straight line. Okay, let's go to the next question. In the alignment plane, the points represented by the complex numbers 2 minus 6i, 4 minus 7i, 3 minus 5i, and 1 minus 4i form. What do they form? Do they form a parallelogram, rectangle, rhombus, or a square? Okay, let us discuss. The points represented by these complex numbers. So 2 minus 6i, then 4 minus 7i, 3 minus 5i, and 1 minus 4i. 2 minus 6i, it is represented by the point 2 minus 6, and this 4 minus 7i is represented by the point 4 minus 7. Similarly, 3 minus 5 and 1 minus 4. So now what they are actually asking is, these 4 points, what do they form? Do they form a parallelogram, rectangle, rhombus, or square? So I will name these 4 points as A, B, C, and D. So then to check what do they form, I will go for distance formula. First I will find out AB. AB is equal to square root of find the distance between these two. 4 minus 2 is 2, 2 square is 4, plus minus 7 plus 6, minus 1 whole square. So AB is equal to root 5. Then BC, that's equal to 3 minus 4 minus 1 whole square is 1, plus minus 5 plus 7 which is 2, 2 square is 4, this will give you root 5. Then CD, that's equal to 1 minus 3 is minus 2 whole square, which is 4, plus minus 4 plus 5, 1, that's equal to root 5. AB, BC, CD, and then DA, that's equal to square root of 1 minus 1 is minus 1 whole square is 1, plus minus 4 plus 6 which is 2, 2 square is 4, that's equal to root 5. Okay. So this suggests that all the 4 sides are equal. When all the 4 sides are equal, then that quadrilateral may be a square or it may be a rhombus also. So then what do? We will find the diagonals. If the diagonals are also equal, then they represent a square. If the diagonals are not equal, then it forms a rhombus. So I will find out AC. AC, that's equal to square root of 3 minus 2 is 1, 1 square is 1, plus minus 5 plus 6, 1 whole square is 1. This is equal to root. Then BD, the other diagonal, is equal to BD. 1 minus 4 minus 3 whole square is 9, minus 4 plus 9. So root 18. AC is not equal to BD. All the 4 sides are equal, but the diagonals are not equal. Therefore, they form a rhombus. Okay. Let's go to the next question now. The condition for the points Z1, Z2, Z3, Z4 parallelogram. The condition for them to represent a parallelogram, which we discussed already in our previous class. In a parallelogram, diagonals bisect each other. So Z1 plus Z3 by 2, midpoint of one diagonal is equal to the midpoint of the other diagonal. Z1 plus Z3 by 2 is equal to Z2 plus Z4 by 2. This will imply that Z1 plus Z3 is equal to Z2 plus Z4. Second option. Then, in the argument plane, the points are represented by the complex numbers 9i minus 2 plus 7i, 1 plus 4i and 3 plus 6i form. Let us see what they form. They are represented by the points, I call the first point as A, which is 9i, that is represented by 0, 9. Then the B, minus 2 plus 7i, which is minus 2, 7. C, 1, 4 and D is 3, 6. I'll find the distance between these points. AB is equal to minus 2 minus 0 minus 2 whole square is 7. 4, then 7 minus 9 is minus 2 whole square, which is 4. This will give you root 8. Then BC is equal to 1 plus 2, 3 square is 9 plus 4 minus 7 is minus 3 whole square is 9. This will give you root 18. Then CD is equal to 3 minus 2 whole square is 4. 6 minus 4 is 2 whole square is 4. This will give you root 8. Then DA, that's equal to 3 minus 0. 3 square is 9. Then 6 minus 9 is minus 3 whole square is 9. Root 80. As we can observe, opposite sides are equal. When the opposite sides are equal, it is a rectangle or it could be a parallelogram also. So let us find out the diagonals. If the diagonals are equal, then they form a rectangle. If the diagonals are not equal, then they form a parallelogram. AC is equal to root of 1 minus 0 is 1, 1 square is 1, 4 minus 9 is minus 5, whole square is 25. So this will give you root 26. Then BD is equal to root of 3 plus 2, 5 square 25. 6 minus 7 is minus 1 whole square, root 26. Opposite sides are equal. Opposite sides are equal, diagonals are also equal. Therefore, they form a rectangle. Then, statement 1. If A and B are positive real numbers, then the root of minus A into root of minus B is equal to root A. That is the first statement. Second statement is the argument of 1 plus I root 3 divided by 1 minus I root 3 is 123. Okay? The argument of 1 plus I root 3 by 1 minus I root 3 is 123. Options are only one is true, that is only first statement is true, only second is true, both are true, neither is true. Okay. So let us verify the first statement. A and B are positive numbers, then root of minus A into root of minus B is equal to root of A. Let us check. Root of minus A into root of minus B. That's equal. Root of minus A can written as root of minus 1 into root A. So root of minus 1 is I into root A. Similarly, this will be I into root A. So you will get I square into root of A. What is the value of I square? I square is minus 1. So answer is minus root of AB. This product will be equal to minus root of AB, but they have given root of AB. Hence, statement 1 is wrong. Statement 1 is false. Okay. Statement 1 is false. Now let us check the statement 2. Second statement we should verify. Argument of 1 plus I root 3 by 1 minus 1. I take Z1 is equal to 1 plus I root 3 and Z2 is equal to 1 minus I root 3. Now we are asked to find out argument of Z1 by Z2. Argument of Z1 by Z2, for this we know one formula, that is equal to argument of Z1 minus argument of Z2. That's equal to argument of Z1. Look at 1 plus 1. Argument is something called the amplitude. So I want the amplitude of 1 plus I root 3. 1 plus I root 3, here x is equal to 1, y is equal to root 3. So it lies in both are positive. So it lies in the first quadrant. In the first quadrant, theta is equal to alpha. What is alpha? Alpha is equal to, you know the formula, tan inverse of mod of y by x. That's equal to tan inverse of modulus of y by x. Root 3 by 1. So root 3 tan inverse of root 3 is pi. Alpha is equal to theta here. So theta is equal to pi by 3 today. So argument of z1 is pi by 3 minus argument of z2. Z2, you observe, it is the conjugate of 1 plus I by 3. So if theta is the amplitude of z, then the amplitude of its conjugate z bar will be minus theta. So now z1, the amplitude of z1 is pi by 3, therefore amplitude of z2, this being the conjugate of this, will be minus pi by 3. So we get pi by 3 plus pi by 3, that's equal to 2 pi by 3 in terms of radians, in terms of degrees is equal to 120 degree. So second statement is true. First statement is false and second statement is true. So only 2 is true is the right answer. Okay. Here is the next question. Here also there are given 2 statements. Now we have verified among them which is correct and which is wrong. If z is equal to z bar, then z is purely imaginary. Statement 2, if z is equal to minus z bar, then z is purely real. Okay. So first statement I will like to verify. Z is equal to z bar. I take z is equal to x plus iy. So z is x plus iy. Given that z is equal to z bar, if z is equal to x plus iy, z bar is the conjugate of x plus iy. That will be x minus iy. X minus iy. Right? So this will imply that x gets cancelled. Bring minus iy here. Iy plus iy will get 2iy equal to 0. This implies when the product is 0, then this is 0, this is 0, but I cannot equal to 0. So y is equal to 0. Y is equal to 0 means imaginary part is 0. For a complex number, if the imaginary part is 0, then we say that it is purely real. So, if z is equal to z bar, then z is purely real. But what they have given? They have given the statement that z is purely imaginary. Therefore, statement 1 is false. Let us look at statement 2. Statement 2 says that z is equal to minus z bar. Then z is purely real. Let us verify this. Z is x plus iy is equal to minus of z bar. Z bar is x minus iy. So this will give you x plus iy is equal to minus x plus iy. Minus of minus iy will give you plus iy gets cancelled. Bring this to LHS. We do x equal to 0. That will imply that x equal to 0. X equal to 0 means real part is 0. Therefore, z is purely imaginary. So what they are doing? They are given that z is purely real. So both the statements are false. So neither 1 nor 2 are true. Actually, it should be the other way around. The actual statement is if z is equal to z bar, then z is purely real. And if z is equal to minus z bar, then z is purely imaginary. This is the correct statement. Remember that statement. However, here the given statements both are wrong. Okay. Let's look at the next question. Match the following. See here in the first column they are given the complex number, and in the next column they are given the polar form of all those complex numbers. Okay. So first we will look at this 1 plus 2 3 i. Polar form and polar form is r into cos theta plus I sin theta, or r into cis theta. Okay. So first I would like to find the r for this. Root of x square plus y square root 4, which is equal to 2. Modulus is 2. Then theta 1 plus root 3i lies in the first quadrant. Both are positive, x and y lies in the first quadrant. So theta is equal to alpha. Alpha is equal to tan inverse of modulus of y by x root 3 by 1. This is equal to pi by 3. So first complex number can be written as 2 cis pi by 3. That means 1 should be matched with A. 1 is matched with A. Look at the options. Here 1 is matched with A, here also 1 is matched with A. Here 1 is matched with B, 1 is matched with C. Therefore, these two options are eliminated. Answer is either the first option or the third option. Okay. Then I will take the second one, 1 minus root 3i. 1 minus root 3i, it is the conjugate of 1 plus root 3i. So, modulus will remain the same and amplitude will be negative of the amplitude of this. For the first one, amplitude is pi by 3. Therefore, for this, the amplitude is minus pi by 3. Which means this 1 minus root 3i, its polar form will be 2 cis minus pi by 3. 2 cis minus pi by 3. So 2 should be matched with D. Those two already we have mentioned. Here 2 is matched with C, whereas here 2 is matched with the D. Therefore, this is the right answer. Option C is the correct answer. Okay, let's have a look at this 80th question. If the complex number z is equal to x plus iy satisfies the condition mod z plus 1 is equal to 1, then z lie on. Where does it lie? On x axis or y axis? It lies on a circle with center at 1, 0 and radius 1, and circle with center at minus 1, 0 and radius 1, y axis. Okay, so mod of z plus 1 is equal to 1. Can I compare this with the mod z minus z naught is equal to r? Now you might say, sir, here plus 1 is there, minus z naught is there. That's not a problem because I can write this as z minus of minus 1. Okay. So now we can compare. You already know what does this represent? Yes? Yes, you are right. Mod z minus z naught is r represents a circle with center at z naught and a radius r. So this represents a circle with the center at minus 1 and a radius 1. Center at minus 1 means I am talking about minus 1 comma 0. So this represents a circle with the center at minus 1 comma 0 and a radius 1. Circle with center at minus 1 0 and a radius 1. If you know this formula, directly right? If we don't know what we have to do, that is your doubt, right? So I will explain what you have to do if you don't know. Of course, I advise you to remember this formula. If you don't know that formula, even then you can solve it. Z plus 1, Z I write as x plus iy plus 1 is equal to 1. So this is modulus of x plus 1 plus iy is equal to 1. It is root of x plus 1 whole square plus y square equal to 1. Square this, you get x plus 1 whole square plus y square is 1 square is 1. So this represents a circle with a center at minus 1 comma 0 and a radius 1. Okay? Then the area of the triangle on the complex plane formed by the complex number z minus iz and z plus iz is. Okay, so there is a standard formula. The area of the triangle formed by z, iz and z plus iz is 1 by 2 into mod z square. That is this answer. Now, even for this also, for z minus iz and z plus iz, the area is half into mod z whole square. Okay, I advise you to remember this as a formula. Okay. However, for your confirmation, I will give you the proof. But in the exam, in any of the competitive exam, be it CAT or mains, you will not have that much time to prove this result. You better remember this as a formula. But here now I will give you z is equal to x plus iy. Then I want minus iz, right? Minus I into x plus iy. That's equal to minus ix minus I square plus 1. Then z plus iz means x plus iy plus I into x plus iy. It will become x plus iy plus ix minus y. I square y, I square is minus 1. So I can write this as x minus y plus I into x plus y. Okay, so now we have three complex numbers here, z minus iz and z plus iz. Z is x plus iy, which is represented by the point x comma y. Then minus iz is nothing but minus ix plus y, or I can write that as y minus ix. Then in terms of order of the pair, it is represented by y comma minus x. Then this is the second point. The third point is z plus iz, which is this. So this is represented by x minus y, comma x plus y. Okay. So now we have 3 points. I can call it as x1, y1, x2, y2 and x3. If x1, y1, x2, y2 and x3, y3 are the 3 vertices of a triangle, then what is the formula to find the area of that triangle? You already learnt determinants. Through determinants, there is one formula to find the area of the triangle. What is that formula? Area of the triangle is given by half into determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1. Do you remember this formula? Yes, use that formula. Half into determinant of in place of x1, we have this x, y, 1. Here y minus x, 1. And here x minus y, x plus y, and 1. Okay. Now we have to evaluate this determinant. I'll change the third row. I'll change R3 as R3 plus R2 plus R1. I'll add on. That's equal to 1 by 2 into first and second row will remain as it is. In the third row, I am adding x minus y plus x. So y gets cancelled, you get 2x. Here x gets cancelled, you get 2y. Here 1 plus 1 plus 1, 3. That's equal to 1 by 2 into expand this x into minus 3x minus 2y minus y into 2y square plus 2x square plus 1 into sorry, I made a mistake here. Minus y into 3y minus 2x plus 1 into 2y square plus 2x square. Okay, that's equal to, let us further simplify it. Half into minus 3x square minus 2xy minus 3y square plus 2xy plus 2y square plus 2x. Okay. Observe that 2xy is cancelled. 2x square minus 3x square, you get minus x square minus 3y square plus 2y square, that is minus y square. We are finding the area. Area cannot be negative, so I will take modulus here. So it will become plus x square plus y square by x square plus y square can be written as mod z whole square. I have taken z as x plus iy, so mod z will be equal to root of x square plus y square. So mod z whole square is x square plus y square. So the answer is mod z whole square by 2. This is the answer. Option C. Okay. This is for you to understand, but I advise you to remember this as a formula so that you can directly write the answer. Okay. Let's have a look at the next question. The number of solutions of the equation z square plus mod z whole square is equal to 0 is z square plus mod z whole square is equal to 0. So how many solutions does this have? That's the question. Okay. So I will write mod z whole square as z into z bar. Okay. You know z is equal to x plus iy if I take it, then z bar is equal to x minus iy. Z into z bar is equal to a plus b minus b, a square minus b square, that will be x square minus a square plus b square, x square plus y square. Okay? Z into z bar. Now I take z as a common factor here. Then what will remain? Z plus z bar. Okay? Is equal to 0. What is z plus z bar? Z plus z bar is equal to x. If I add these two, iy gets cancelled. 2x. So z into 2x equal to 0. This implies that either z is equal to 0 or x equal to 0. Okay? X equal to 0 means y can be any real, right? Which means there are infinitely many points. So for all x equal to 0, when y can be any real number, all of those will be solutions. In other words, all the complex numbers which are purely imaginary, all those will be the solutions of this complex number. Okay? Or I can put it in another way also. Z square is equal to x plus iy that's equal to x square minus y square plus 2ix square. Mod z whole square, that is x square plus x. So if I substitute here, I'm going to get x square minus y square plus 2ixy plus mod z whole square, that is x square plus y square is equal to 0. Y square is cancelled. 2x square plus 2ixy is equal to 0. And then 2x as common, 2x into x plus iy is equal to 0. And the product is 0, either this is 0 or this is 0. So if x is 0, that's 0. So how many complex numbers are there where x is 0? There are infinite many. X is 0 means I am talking about y axis. In other words, I am asking how many points are there on y axis. There are infinitely many. So the answer is it has infinitely many solutions. Fourth option. Okay. Next question. The amplitude of sin pi by 5 plus I into 1 minus cos pi by 5 is sin pi by 5 plus 1 minus plus I into 1 minus cos pi. Let me simplify this. It looks like sin theta. Sin theta can be written as 2 sin theta by 2 cos theta. So this will give you 2 sin theta by 2 pi by 5 by 10 cos theta by cos pi plus I into 1 minus cos theta, that is 2 sin square theta, 2 sin square pi by 10. I will take 2 sin pi by 10 as a common factor. Then what will remain here? Cos pi by 10 plus I sin pi by 10. Okay? You just observe here. This complex number looks like r into cos theta plus I sin theta. R into cos theta plus I sin theta. So this is already in the polar form. R into cos theta plus I sin theta. What is the question? Amplitude. So what is theta? Cos theta plus I sin theta. Theta is equal to pi by 10. Pi by 10. Fourth option is the answer. Okay, let's have a look at question 25. The real value of alpha for which the expression 1 minus I sin alpha divided by 1 plus 2I sin alpha is purely real. So what is the value of alpha such that this complex number is purely real? Purely real means its imaginary part must be equal to 0. So first we shall find out what is its imaginary part, then we will equate it to 0. But before I find out what is its imaginary part, I have to ensure that it is in the standard form. Standard form means a plus ib or x plus iy. Okay. So for that I will simplify this. I will multiply and divide by the conjugate of the denominator. Okay. Then in the numerator we will have 1 minus 2I sin alpha minus I sin alpha plus 2I square. I square is minus 1, so it will become minus 2 sin square alpha divided by, it will become 1 plus 4 sin square alpha. A plus b minus b square minus b square. 4 into 4 I square sin square alpha. I square is minus 1. Minus of minus 2. So 1 minus 2 sin square alpha minus 3I sin alpha divided by 1 plus 4 sin square alpha. Okay. So now this is in a plus ib form. Or if you want, I write one more step. 1 minus 2 sin square alpha, or you can write as cos 2 alpha divided by 1 plus 4 sin square alpha plus I into minus 3 sin alpha divided by 1 plus 4 sin square alpha. Okay. So observe that it is in the form a plus ib. This complex number is in the form a plus ib. Now they have given that this is purely real. Purely real means imaginary part must be equal to 0. So this must be 0. Minus 3 sin alpha divided by 1 plus 4 sin square alpha equal to 0. This will multiply this product becomes 0. So minus 3 sin alpha which will imply that sin alpha is equal to 0. Sin alpha is equal to 0 means what is the value of alpha? Alpha is equal to 0. 0 is one of the values. But alpha is equal to pi. Then also sin pi is 0, sin 2 pi, sin 3 pi, sin 4 pi, sin 5 pi, etc. Every multiple of pi. Or in general, n pi alpha is equal to n pi. Because you go on putting values for n. N is any natural number. Okay? If I put n as 1, sin pi, put n as 2, sin 2 pi, sin 3 pi, n can be an integer also. But here they have given n belongs to n. Okay, so this is a subset of the set of all integers. So alpha is equal to n pi is the correct answer. Okay. N pi. The value of z plus 3 into z bar plus 3 is not visible properly. Z plus 3 into z bar plus 3. Okay, so now z plus 3 into z bar plus 3 can be written as 3 bar because 3 is a complex number which can be written as 3 plus I into 0. What is its conjugate? 3 minus I into 0, which is same as 3, right? So 3 can also be written as 3 bar. Then together we know one formula, z1 bar plus z1 plus z2 whole bar is equal to z1 bar plus z2 bar. Do you remember this formula? Yes, you must be, because I made one mistake there in that first video. I wrote it as z1 bar into z2 bar. But actually it is a formula, z1 plus z2 bar whole bar is equal to z1 bar plus z2 bar. So if I use that formula, I can write this as z plus 3 whole bar. Okay. So now this is as good as z into z bar. What is z into z bar? Z into z bar is equal to mod z whole square. So this is equal to mod of z plus 3 whole square. Mod of z plus 3 whole square, which is the first portion. Okay, so look at question 91 here. The point represented by a complex number 2 minus I is rotated about origin through an angle pi by 2 in the clockwise edge. The new position of the point is. Okay. So one small concept which I had already explained in last class, still I prefer to explain it again. Say choose a point P. This point P represents a complex number, let us say a complex number Z. Then we are rotating this OP through this position. We are rotating this point P through this position in through an angle theta. Through an angle theta in the anti-clockwise direction. Then this point is given by z into cis theta. This point represents the complex number z into cis theta. If you rotate it through an angle theta in the anti-clockwise direction, but if you are rotating it through an angle theta in the clockwise direction, then this point, identified as r, it is represented by z into cis of minus theta. Okay? So here z is 2 minus I. This point is there. Then that complex number, that point is rotated through an angle pi by 2 in the clockwise direction. So theta is pi by 2 here. It is rotated in the clockwise direction. So the new position is given by z into, I call this as z. It is given by z into cis of minus theta. So z into cis of minus pi by 2. Angle is minus pi by 2. Okay. Z is 2 minus I into cis of minus pi by 2. That will give you cos of minus pi by 2, which is cos pi by 2, that is 0, plus I sin of minus pi by 2. Sin of minus pi by 2 is minus 1, so minus I multiply minus 2I plus I square. Okay? Plus I square is minus 1. So answer is minus 1 minus 2I. Do we have this option? Yes, we have. Second option. Is it clear? So when a complex number is rotated through an angle, when it is represented here, when it is like OP, if it is rotated through an angle theta in the anti-clockwise direction, then the new point represents a complex number z into cis theta. If it is rotated through an angle theta in the clockwise direction, then it is represented by z into cis of minus theta. Okay, so here the answer is minus 1 minus 2. Okay. Next question. The complex number z which satisfies the condition mod of I plus z by mod of I minus z is equal to 1 lies on. Modulus of I plus z can also be written as z plus I. I minus z can also be written as z minus z. Modulus of I minus z is same as modulus of z plus is equal to 1. This is of the form. Yes, can you? Yes, right. Z minus z1 by z minus z2 is equal to 1. It represents z minus z1 by z minus z2 is equal to 1. What does it represent? Very popular form. It represents the perpendicular bisector of the line joining z1 and z2. So this represents the perpendicular bisector of the line joining minus I and I. Minus I is represented by 0, minus 1 and I is represented by the point 0, 1. Okay, so 0, minus 1 is here, 0, 1 is here. The perpendicular bisector of AB is nothing but x-axis. That's the answer. Then, 96th question. Modulus of z1 plus z2 is equal to mod z1 plus mod z2 is possible if z2 is equal to z1 bar, z2 equal to 1 by z2, argument of z1 equal to argument of z2, mod z1 equal to mod z2. Okay. This requires some explanation. See, in general, modulus of z1 plus z2 is always less than or equal to mod z1 plus z2. So, in some special cases, mod z1 plus z2 will be equal to mod z1 plus mod z2. So, when it is true, let us say. Okay. So, I take z1 as r1 into cis theta 1 and z2 let me equal to r2 into cis theta 2. Okay. Then z1 plus z is equal to r1 into cis theta 1 I write as cos theta 1 plus cos theta 2. Sorry, cos theta 1 plus I sin theta 1 and z2 as r2 into cos theta 2 plus I sin theta 2. Okay. Now I will group all the real parts together. R1 cos theta 1 plus R2 cos theta 2 plus I into R1 sin theta 1 plus R2 sin theta 2. I have grouped the real part together and the imaginary part together. So I am expressing it in the form A plus I. So this is our z1 plus z, x plus iy. Now I would like to find out modulus of z1. I am actually deriving a formula for this modulus of z1 plus z2 whole square. Then I will come back to this problem. Okay. Mod z1 plus z2 whole square. So mod z is equal to root of x square plus y square. So mod z whole square is equal to x square plus y square. So this will give you r1 cos theta 1 plus r2 cos theta 2 whole square plus y square, that is r1 sin theta 1 plus r2 sin theta 2 whole square. Let us expand this using a plus b whole square. R1 square cos square theta 1 plus r2 square cos square theta 2 plus 2 r1 r2 cos theta 1 cos theta 2 plus expand this r1 square sin square theta 1 plus r2 square sin square theta 2 plus 2 r1 r2 sin theta 1 sin theta 2. Okay, that's equal to. Now I'll group these two. I'll take r1 square as common. R1 square if I take common, cos square theta 1 plus sin square theta 1, that is 1. So r1 square plus. Then I will group these two terms. From those two I will take r2 square as common. If I take r2 square as common, then we are left with cos square theta 2 plus sin square theta 2, which is 1. Plus from the remaining two terms I will take 2 r1 r2 as common. We are left with the cos theta 1 cos theta 2 plus sin theta 1 into sin theta 2. Okay. So now we have mod of z1 plus z2 whole square is equal to r1 square plus r2 square plus 2r1 r2 into, look at this, it looks like cos a cos b plus sin a sin b. Cos a cos b plus sin a sin b is equal to cos a minus b. So this will give you cos of theta 1 minus theta 2. Cos theta 1 minus theta 2. Okay. So then mod of z1 plus z2 whole square is equal to r1. I can write it as mod z1. I have taken z1 as r1 since theta 1. So modulus of z1 is r1. I can write this as mod z1 square plus this is mod z2 square plus 2 into mod z1 into mod z2 into cos of theta 1 minus theta 2. Where theta 1 is the argument of z1 and theta 2 is the argument of z2. This formula you have to remember. Okay. Proof is just for your knowledge. In the exam, in the CT exam, they will not ask you to prove it. Anyway. So remember this formula. I'll write it here. Modulus of z1 plus z2 whole square is equal to mod z1 square plus mod z2 square plus 2 into mod z1 into mod z2 into cos theta 1 minus theta 2. Okay. Now this expression cos of theta 1 minus theta 2, cos of any angle, is always less than or equal to 1. So therefore this product is always less than or equal to 2z1 z2. Okay. When this is equal to 1, then this will become z1 plus mod z1 plus mod z2 whole square. So then we can write modulus of z1 plus z2 as mod z1 plus mod z2. So therefore if I take the square root here, I can write mod z1 plus z2 in general it is always less than or equal to mod z1 plus mod z2 because this fact is always less than or equal to. When it is equal to 1, these two will be equal. Okay. So now coming to this, they have given that mod z1 plus z2 is equal to mod z1 plus mod z2. Okay. See, so far with respect to this problem, whatever I have explained is the general result. It has got nothing to do with this. This is a general formula which I have derived. You need to remember this and you need to remember this also. Okay. Now I am solving this problem. So then given modulus of z1 plus z2 is equal to modulus of z1 plus mod z2. Then I will square this expression. Squaring this will give you mod z1 square plus mod z2 square plus 2 into mod z1 into mod z2. Okay. So in place of this I will mod z1 square plus mod z2 square plus 2 into mod z1 into mod z2 into cos of theta 1 minus theta 2. On RHS you have mod z1 square plus mod z2 square plus 2 into mod z1 into mod z2. So mod z1 square and mod z2 square gets cancelled. We are left with 2 into mod z1 into mod z2 into cos of theta 1 minus theta 2 is equal to 2 into mod z1 into mod z2. Okay, so 2 gets cancelled, mod z1, mod z2 gets cancelled. Then we are left with cos theta 1 minus theta 2 is equal to 1. Okay, cos theta 1 minus theta 2 is equal to 1 will imply that theta 1 minus theta 2 is equal to 0 because cos 0 is equal to 1. Hence you get theta 1 is equal to theta 2. Theta 1 is equal to theta 2. Theta 1 is nothing but argument of z1 and theta 2 is the argument of z2. So when these two are equal, this is possible only if argument of z1 is equal to argument of z2. Okay. Let's move to the next question. The value of argument of x when x is less than 0. X is negative. X is negative means it has to be real number because So that x must is negative means x must be a real number. So x is a real number and it is positive. It is a real and positive. So we are talking about a complex number which is purely real and negative. Which is purely real and negative. We are talking about a complex number which is purely real and negative. So it lies on negative x-axis. Lies on this line. Right? If a complex number lies on negative x-axis, then what is its amplitude? Its amplitude is equal to its amplitude is equal to pi. If it is purely real and positive, then its amplitude is 0. If it is purely real and negative, its amplitude is pi. If it is purely real, purely imaginary and positive, then amplitude is pi by 2. If it is purely imaginary and that imaginary part is negative, then its amplitude is minus pi. So for this, the answer is pi. Then, if f of z is equal to 7 minus z divided by 1 minus z square, where z is equal to 1 plus 2i, then modulus of f of z we want that, which is equal to modulus of 7 minus z divided by 1 minus z square. This can be written as modulus of 7 minus z divided by modulus of 1 minus z square, because modulus of z1 by z2 will mod z1 by mod z2. Okay. So I find out these two separately. 7 minus z, that's equal to 7 minus 1 plus 2i. That's equal to 6 minus 2i. Then modulus of 7 minus z is equal to root of 36 plus 4, root 40. Then I want 1 minus z square. That's equal to 1 minus z square. Z is 1 plus 2i whole square. That's equal to 1 minus of expand this 1 plus 2i whole square, that will be minus 4 plus 4i. That's equal to, this will become 4 minus 4i. Right? 1 minus 1 gets cancelled, that plus 4 minus 4i. 4 minus 4i. So modulus of 1 minus z square is equal to root of 16 plus 16, that's equal to root 30. Okay. So modulus of f of z is equal to modulus of 7 minus z, we got root 40, divided by modulus of 1 minus z square, we got root 30. Okay, root 40 can be written as 10 into 4 or 2 root 10 divided by, here 60 into 2. So 4 root 2 gets cancelled, root 10 divided by 2. Root 2 gets cancelled, you can write as root 5 by 2. I'll write here. So modulus of f of z is equal to root 5 by 2. But we want the answer in terms of mod z. What is the value of mod z? Z is equal to 1 plus 2i. Z is equal to 1 plus 2i. Therefore, modulus of z is equal to root of 1 plus 4. That's equal to root 5. In place of root 5, I can substitute mod z. So the answer is mod z by 2. First option. Mod z by 2. First option is the answer. Okay. Let's have a look at the next question. Question number 100. If alpha and beta are two different complex numbers, so with the alpha and mod beta equal to 1, then beta minus alpha divided by modulus of beta minus alpha divided by 1 minus alpha beta, it should be alpha bar into beta. Okay, that's a typing mistake there. Please note that correction. We want to find out they have given that mod beta equal to 1, and we have to find out modulus of beta minus alpha divided by 1 minus alpha bar into beta. Okay, make it as alpha bar. It's treated as alpha, it should be alpha bar. Okay. Say mod beta equal to 1 means mod beta whole square is also equal to 1. Mod beta can be written as beta into beta bar. Okay, mod beta whole square. Mod z whole square is equal to z into z bar. So beta into beta bar is equal to 1. Now I will replace this 1 with the beta into beta bar minus alpha bar into beta. That's it. Here I take beta as a common factor and I will take it outside this. So when I take outside, you do mod beta into modulus of beta minus alpha divided by beta bar minus alpha. That's equal to mod beta is 1. Mod of beta minus alpha divided by beta bar minus alpha bar. Together I can write that as beta minus alpha whole bar. That's equal to mod beta minus alpha divided by mod of beta minus alpha bar. These are the conjugates of each other. When two complex numbers are conjugates of each other, their modulus will remain the same. So their modulus is same, those two gets cancelled. So the answer is 1. Okay? Then let's look at the next question. If 1 minus I whole power 96 by, if 1 minus I whole plus I whole power 96 is equal to A plus IB, then what are A? Yeah, I think you can solve this, not an issue. 1 by multiply, you simplify this, multiply divided by 1 minus I and simplify, you will see that A is equal to 1 and B is equal to 0. Then, okay, this I will let solve. If 1 omega and omega square are 3 cube roots of unity, then what is the value of 1 minus omega plus omega square into 1 plus omega minus omega square? Yes. You know that 1 plus omega square into minus omega. So, and 1 plus omega is minus omega square. Together this will give you minus 2 omega and this will give you minus 2 omega square. When you multiply, you get 4 omega cube. Omega cube is 1, so the answer is 4. Okay. Next question. The real part of 1 plus cos theta plus I sin theta whole power minus 1 is 1 plus cos theta plus I sin theta whole power minus 1 plus cos theta I can write as 2 cos square theta by 2 and sin theta I can write as 2 sin theta by 2 cos theta by 2 whole power minus 1. I take 2 cos theta by 2 as common, then what will remain? Cos theta by 2 plus I sin theta by 2 whole power minus 1, right? So whole power minus 1 means this is what the denominator. We will 1 by 2 cos theta by 2 and here cos theta by 2 plus I sin theta by 2 whole to the power minus 1. Now I can use De Morgan's theorem here. Cos theta plus I sin theta whole power n is equal to cos n theta plus I sin n theta. So this will become 1 by 2 cos theta by 2 into, if I take it inside, cos of minus theta by 2 plus I sin of minus theta by 2. Cos of minus theta by 2 is cos theta by 2 itself and sin of minus theta by 2 is minus I sin theta. Okay. Then take this 2 cos theta by 2 inside, you get 1 by 2 minus 1 by 2 I into tan theta sin theta by 2 by cos tan theta, which means the real part is 1 by 2 and the imaginary part is minus 1 by 2 tan theta. What do you want? Real part or imaginary part? Real part. So the answer is 1 by 2, 4,000. Okay. That's it. With this we have come to the end of complex numbers. I have left in between quite a few problems, that is for you. For homework. So if you have any doubts, you can always ask through WhatsApp groups. In the next class, I will go to the next chapter, which is quadratic equations. Okay, thank you.